Hey guys, welcome back to my YouTube channel. I hope you guys like the hat. It's so cute. I thought it would be good for this video. Yes, guys, welcome back to my YouTube channel. In today's video, we'll be speaking about food chains, food webs, biodiversity. We're going to touch on it just a little bit because we're going to dive further into it as we progress. Um, so it's going to be very interesting. I personally like speaking about food webs and food chains outside of climate change and sustainability, of course. But I think it's so interesting and dynamic how animals and organisms in general work. Um, how they eat and how that helps us to eat as well. I think that's so important, and that's something that many persons overlook. And that's a beautiful thing about the environment is that it takes a lot of things into consideration, so we can appreciate it just a little bit more. So to start off my video, I'm just going to start off with some definitions, just to get the ball rolling, have persons get an understanding of what exactly we're going to dive into, and then speak a little bit on food chains and food webs. So we have some base knowledge to grow on as we continue. So the first word that we're going to define is a word that I use all the time, and it's a word that we hear others use all the time, and that's the word environment. So we always hear the word. What exactly does it mean? And it's actually not a hard word to define. It's just what's around us or environment. It's all the conditions that surround a living organism. So you have different types of environment, of course, but in this case, we're talking about the physical and the natural environment. So what are all the conditions that surrounds us? Or surrounds you, in terms of weather, climate, the types of trees or plants that are near you, the animals that are near you. Where are you situated? That's your environment. Is there a water body close by? All the conditions that surround you is your environment. So it's not a hard word to define. It's a lengthy word, but it's a very simple meaning. Secondly, the next word is habitat, and it is also a simple word to define. The habitat is the place where an organism lives. Where do you live? Do you live in the water? Do you live in a lake, a river, a stream? Um, are you situated on a specific landmark? Are you situated in the forest? Is that your habitat? So it's just where an organism lives. So you can leave your habitat in the chat. Where is your habitat? Hi. Hello. I'm just going on the screen. So I move from like the YouTube studio to the screen that I'm looking at. So I sometimes miss the comments, but hi. Thank you so much for joining. Yeah, so where's your habitat? Um, the third word is population. And things get a bit tricky right here, but it's actually not hard. A population is all the members of a single species that lives in a habitat. Meaning, if you're an ant, all ant species are a part of the ant population. You don't take into consideration other organisms or other species when you're counting population. So you have the human populations, and these are all the humans living in a specific habitat. You have the pig population, all species live in a specific habitat, right? So it's just all members of a single species. Let's say population, and then you go to community, where all the populations of different organisms that live together in a specific habitat. And for me, in terms of defining these words, what I think about is an actual community. Where do you live? I live um, in a community where there is people like me, but there's also cats, dogs, rats, mongoose, all of those stuff. And that's a whole community. It's all the populations of different organisms. You have the you have human species, then you have the dog species, the mongoose species, the rat species, and all of that makes the community. They're all located in this community or this specific habitat. So that's what I use to remember what a community is. It's all populations of different organisms that live together in a specific habitat. And then we have an ecosystem. And an ecosystem is just the community and habitat in which organisms live. It's a closed system where every organism benefits from each other, essentially, which means the food that we eat, the dog can have it. The dog eats the rat, or the cat eats the rat. You know what I mean? It's just a community. We know what a community is, different organisms living in a specific habitat, and how organisms interact with each other in this closed system. So that's essentially it. And as we continue to dive into food chains and food webs, it's important also to define, the term biodiversity. And biodiversity is a measure of the variety of different species that are living in a specific habitat. So the greater the number of different species in a habitat, greater its biodiversity. Meaning, if you only have dogs in a habitat, is it diverse? Yes or no? It's probably not diverse. It's just dogs. But if you have a habitat with dogs, cats, birds, mouses, pigs, cows, goats, it's more diverse because there's more organisms or more different type of species that are living in this habitat. Meaning it's more diverse, and therefore with more different species, there's a greater biodiversity. So that's essentially what it is. And if it's more of the same species, it's less diverse. They have low biodiversity. Which one do you think is better? Greater biodiversity or lower biodiversity? I would say, of course, greater biodiversity is better because it allows um, for some organisms to better adapt to an environment and also withstand any circumstance that may come, like diseases, natural disasters. You can have persons surviving, but rather than if it's just one of the same, then whoop, the habitat is a total wipeout. Whereas if you have more than one, some organisms can adapt, some may not. However, it still leaves a population or a community in the habitat. All right, let's just dive right into food webs and food chains right now. Um, and the interesting thing about food webs and food chains is that it's not that hard to understand, especially food chains where it's a little bit simpler. It's not hard to understand. It's a fairly easygoing topic, which is why I like it. And if you get an understanding of what a food chain is, it's easier for you to build up your understanding on a food web. So every living plant and animal must have energy to survive. Energy is essential. Without energy, I would not be speaking right now. Without energy, I would not even be on this computer right now. I would just be like, I don't even know what I would be like. I don't even want to imagine what I would be like if I did not have energy. Because I would not be able to survive. You must have energy to survive. Now, where our energy comes from is what's different. So even though all of us should have energy, where we get our energy from is where there is a difference. So let's talk about plants first, because who doesn't love like some plants? Plants rely on the soil, water, and most importantly, the sun for energy. So that's where plants get their energy from. Primarily the sun. Primarily the sun. Can't forget the sun is like the driving force of everyone's existence right now. But plants rely on soil, of course, because where plants going to be growing if it's not in the soil? Water, because plants need water to survive. But the sun is most important, and these provide plants with energy. No, it's funny because what could we do without plants? We could do nothing because animals rely on plants as well as other animals for energy. So animals rely on plants. Let's just get that out there. Animals rely on plants. And for those who don't eat plants, animals rely on animals. You see that? At the end of the day, animals rely on plants. So even if you're like, I don't eat plants, I eat this animal. Okay, fine, you eat that animal, but that animal probably eats plants or eats another animal that eats plants. And without that animal, then they are not existing. So you see how funny a food chain and food web is. It's crazy, but it's very interesting. So in an ecosystem, plants and animals all rely on each other to survive. Scientists sometimes describe this as dependence using a food chain or a food web. Um, and I wish I could share my screen so you guys could get a visual representation of this food chain, but I'm going to try my best to describe it using words. So let's talk about a food chain. Right. So we've been saying the word a lot, but let's define what it is. A food chain describes how different organisms eat each other, starting with a plant and ending with an animal. So it's simple. It always starts with a plant and it always ends with an animal. There can be no switch around. There can be no, okay, maybe it starts with a plant today, and an animal today, and then the next day it starts with an animal and it ends with a plant. No, it starts with a plant, it ends with an animal. That's a food chain. For example, you could write a food chain like this. We're going to write a food chain for a lion. It's going to be very short, very simple, but we're going to describe a lion food chain. So first we have the grass. So this is our grass, right? Then we have the zebra. Then we have the lion. Or you could have the grass, the zebra, the lion. I mean, the lion. This is just like an extra thing right here. So you start off with the grass, then you have the zebra, then you have the lion, or you could go up, plants, zebra, lion. Either way, you're starting with the grass, you're ending with the lion, right? So what this means is that there's grass, the zebra eats the grass, the lion eats the zebra. There's grass, the zebra eats the grass, the lion eats the zebra. Are we seeing that? So it goes in that direction. Then you have another example, and this is the food chain of a hawk. You have grass, then you have grasshopper, because a grasshopper eats the grass. Then you have a frog that eats the grasshopper. Then you have a snake that eats the frog. Then you have a hawk that eats the snake. Are you seeing that? So you put everything like this: grass, grasshopper, frog, snake, hawk, and it goes in, energy moves in that direction. Grasshopper is getting energy from the grass, frog is getting energy from the grasshopper, snake is getting energy from the frog, hawk is getting energy from the snake. All right, so links of the chain. There are many names that help describe each link in a food chain. The name depends mostly on what the organism eats and how it contributes to the energy of the ecosystem. So that's where the name base is from. So what does the organism eat and how does it contribute to the energy of the ecosystem? First, we have producers. So plants are producers. There are no other producers but plants. Remember this. Plants are producers. And this is because they produce energy for the ecosystem. They are the base of all energy source in an ecosystem. So they are termed producers. PP. Plant produces. Plants are producers. They do this because they absorb energy from sunlight through photosynthesis. They also need water and nutrients from the soil, which we mentioned before, but plants are the only place where new energy is made. That's so interesting. Plants are the only place where new energy is made. How many people knew that? Let's see if I comment in the chat. Let's see if anyone else is commenting. If you knew that plants are the only place where new energy is made, leave a comment. Okay. All right, so we have producers, which are plants. Then we have consumers, and consumers are everything that follows producers or follows plants. So consumers are animals. So animals are consumers, and this is because they don't produce energy; they just use it up. Animals, I tell you, we don't produce energy; we just use energy up. That's so sad comparing us to plants because plants just seem so proactive and useful and smart because they're making new energy versus animals that just don't make any energy. We just use all the energy that the plants made up. Like we just use it up. That makes us unique, right? So, so animals eat other animals, and those are called secondary consumers. But before we reach that, so animals that eat plants are called primary consumers or herbivores. So who is a primary consumer? An animal that eat plants. Who is an herbivore? An animal that eat plants. So herbivores and primary consumers are the same thing. All right. Now, animals that eat other animals are called secondary consumers or carnivores. So if you're an animal that eats other animals, you're a carnivore or you're a secondary consumer. Now, if a carnivore eats another carnivore, it is called a tertiary consumer, right? So if you're a carnivore that eats another carnivore, you're a tertiary consumer. right? Or if you're a carnivore that eats a herbivore, you're a secondary consumer. You see? So some animals play both roles. So they eat both plants and animals. And if you eat both plants and animals, you're called a omnivore. All right. So let's just get those words out there. So if you eat plants and animals, you are omnivore. If you eat just animals, if you're an animal that eats another animal, you're a carnivore. Or if you're an animal that eats plants, you're an herbivore. Right? Now, decomposers are another term. So you have producers, consumers, decomposers. Now, decomposers eat decaying matter like dead plants and animals, and they help put nutrients back into the soil for plants to eat. So they're not all bad and disgusting or anything. They actually help the food web and the food chain because they place nutrients back into the soil for plants to eat. So we need decomposers. So some examples of decomposers are worms, bacteria, and fungi. Let's go back to this example, the example of the lion. So we have the grass, the zebra, the lion. Can anyone guess who is the producer in this food chain? Based on what we just said, who is the producer? The grass, the zebra, or the lion? You can answer in your mind, or you could comment below. So the producer in this case would be the grass. The grass is making its own energy. It's getting energy from the sun. Now, who's our primary consumer? Remember, primary consumer is like our herbivore, the one that's eating the plants. In this case, it'd be the zebra. The zebra is our primary consumer. And then you have the lion. And can anyone guess what the lion is? Remember, the lion is an animal eating another animal. And in this case, they're the secondary consumer. All right. And that the lion is a carnivore eating a herbivore, right? So it's a secondary consumer. But if it was another animal that's eating a lion, what's an animal that eats a lion? I don't know, whatever that animal is, if it's an animal that's eating the lion, it would be a tertiary consumer because in this case it's a carnivore eating another carnivore. Are you seeing that? Let's go again. So the zebra is a herbivore, it's eating plants. The lion is a carnivore because it's eating the zebra, which is an animal, right? So anything that follows the lion is going to be a tertiary consumer because it's an animal that's eating an animal that eats an animal. Are we seeing that? So it's a carnivore that's eating a carnivore. I hope you guys see that and can visualize that mentally. Or if you can't, you can just get a piece of paper, get a pencil, and like just draw it out, and you'll get a better understanding of what I'm trying to say. All right, so energy is lost. Energy is not going to remain high all the time. In a food chain, in a food web, energy is lost. So, like we said above, all the energy made in the food chain comes from producers or plants, which convert sunlight into energy with, of course, photosynthesis. Now, the rest of the food chain just uses energy. Remember that animals, we just use it up, we don't make it. Plants are the only one that makes it. So, as you move through the food chain, there is less and less energy available. You have our plants that makes energy, and the food chain moves in this direction with different animals. No, you have the one plant. Well, not the one plant, of course. The whole line of grass then. And then you have about 15 or 20 different animals that follows. And the grass is the only one that's making energy. And everyone else is an animal that's just using energy up. And there's no more new energy being created as the chain progresses. Energy is going to be lost. Energy is going to be lost. Because there's no one else down the chain making more energy. It's not even like plants, animals, plants, animals. So there's some energy being created in this gap. There's no energy being created after they get energy from the grass. There's just no energy. So that's important to note. So energy is lost as the food chain progresses. Energy is going to be lost, and for this reason, there are less and less organisms the further along the food chain you get. Meaning, you're not going to have like 30, 40 organisms after grass, because there's not going to be enough energy for the organism all the way down there. So it's very limited. So in our example above, there is more grass than zebras and more zebras than lions. So the zebras and lions use of energy doing stuff like running, hunting, breathing, sweating, losing heat. They're using up all the energy that they have gained from the grass. So imagine a zebra has eaten. It goes and eats some grass. Oh, it's full of energy now. So now it can run and breathe and hunt and everything. Well, it doesn't hunt, of course, because it eats the grass. But literally, it just runs and breathes, and it's just using up all of that energy, right? Then the lion eats that zebra, and it also runs and hunts and breathes and loses heat. All of that energy is being used up, right? At the end of the day, it's going to be more grass. Of course, you have different food pyramids, where it's kind of upside down. But we're not going to talk about that today. But just know there's more grass than zebras, and there's more zebras than lions. So that means lions can only eat a certain amount of zebras. Zebras can eat, the grass that's available, and so on and so forth. Now, each link is important. Links higher up in the food chain rely on lower links. So even though lions don't eat grass, they wouldn't last long if there wasn't any grass, because then the zebras wouldn't have anything to eat. And if the zebras don't have anything to eat, they have no energy. And if you have no energy, you don't survive, as we mentioned before, which means lions won't have any food and eventually lions won't survive. So you see how each link in that food chain is very important, because without one, the other would not be able to survive. Let's just touch on food webs real quick. So a food web, in any ecosystem, there are many food chains, and generally, most plants and animals are part of several chains. So they're all going to start to become interlocked. When you draw all the chains together, you end up with a food web, right? So if you put all the food chains in an ecosystem together, you're going to find a lot of this going on. One animal eats this animal, one animal eats this animal, and this animal, and this animal. And there's a lot of interlocking going on, and then that creates a food web, which is a little bit more complicated, but it can still be understood. All right, let's talk about trophic levels real quick. And this is what we're going to speak about last, before we end off our topic. Now, trophic levels, sometimes scientists describe each level in a food chain with a trophic level, right? Not food chain, my apologies. Sometimes scientists describe each level in a food web with a trophic level. So here are 5 trophic levels. So you have level 1, which are plants, producers. Level 2, which are animals that eat plants or herbivores, primary consumers. You have level 3, animals that eat herbivores. These are secondary consumers or carnivores. Animals that eat carnivores, tertiary consumers and carnivores. Level 5, animals at the top of the food chain are called apex predators, and nothing eats these animals. Imagine being an apex predator. Nothing eats you. I think humans are kind of apex predators, because nothing really eats other humans. You know what I mean? In terms of like carnivorous humans, of course, which are very rare, especially in modern day society. We're apex predators. That's something to be thankful for. Nothing eats us. Of course, we die probably of different ways, or whatever the case may be. That's not the point. The point is nothing eats us. We don't fear that there's gonna be like a superhuman that eats us or depends on us to survive. You know what I mean? Of course, we have animals that can harm us, and see us as food sometimes. Yeah, don't get twisted. But we don't live in fear of being prey of animals, if you get what I mean. All right. So we're apex predators in a sense. And I guess a lion is also an apex predator. They don't really live in fear of other animals trying to eat them. They are more the hunters. So that's the whole thing. No one hunts us for food as food. No one hunts us. Like crocodiles don't go out on a hunt for humans, or lions don't go out on a hunt for humans versus how they would for zebra. You know what I mean? So apex predators, that's what it means. And yeah, so that's essentially introduction to the food chain and food web. We're gonna dive deeper into biodiversity, because I think it's a very interesting topic. So we're gonna speak on it just a little bit more as we progress. But yeah, I thought it was very interesting speaking on food chains and food webs. You can comment the best thing that you've learned, anything interesting that you've learned. I definitely mentioned a lot of interesting points. So it would be great to see what you think you understood. Thank you so much for joining. Last the dream. Thank you so much for commenting. Really appreciate it. And I hope to see you in the next video. Have a great day, guys. Remember to like, share, and comment, and be a part of the Young Empowerers family. You have a lot more to learn. See you in the next video. Bye, guys.